So today we are going to find surface area and lateral area for pyramids and cones. We're going to do these together because the process is really similar. Just got a couple pictures here for you guys. So a regular pyramid is all we're dealing with. So regular pyramid just means that the base is going to be a regular polygon. Regular polygon means all the sides are the same and all the angles are congruent. And what happens when you have a pyramid, you just have one base, and then the lateral faces are, just as you see in the picture here, they're triangles, and then they fold up to a point that's called the vertex. Okay, now when you're doing lateral area and surface area, there's two different heights that we talk about. The height of the pyramid is the distance at a perpendicular from the base to that vertex. If you look at a picture here, that's this distance. Now, we will use that for volume, but we will absolutely not use that for lateral area or surface area. So what we use for that is called a slant height. So the slant height is the height of each of the lateral faces, each of the triangles that you see in a pyramid when you're looking at it. And so here, the slant height is the height of that triangular face. So I've got a little three-dimensional pyramid. I know this is not the best to see on the video here, and it's clear as well. So just want to reiterate, the height would come up through the middle, and I'm not displaying that well, but the slant height, you would be able to touch it if you had a physical representation of the figure like I have kind of drawn here. I have this triangular face and I drew the height in. I can touch that. The actual height of the pyramid is the distance from like where my paper's at up to this vertex. I can't touch that. It would be inside the pyramid. So those are the differences there. Okay, so I just have several examples of nets of pyramids. This has a square base, this has a hexagon as a base, this has a pentagon, this has a triangular base. If you folded each of these up, right here, little height of each of these triangles, and I'd have to have like little right angles in there, that would be your slant height. So you're not able to see the actual height of the pyramid because it's not folded up from the net, but you could draw in, like I said, the slant height is just going to be the height of each one of these triangular lateral faces, and you need that to be able to find the area of that triangle. All right, just like we did for lateral area of a prism or a cylinder, the lateral faces don't include the base. So here, each one of these nets, it would be the not shaded part, so they're each triangles. All right, so your lateral area, because we're dealing with triangles here, you're going to see a 1/2. If you think about the area of a triangle for just a normal formula, 1/2 base times height. Okay, now I want to do, like as an example here, all 4 of these or all 6 of these triangles at one time. So instead of just doing 1/2 base times height for each one, if I do the perimeter of the base, that gives me the base of all the triangles. And then we're going to do slant height, which is represented with an L. So I'm just going to write this to the side, kind of a cursive L. That's what we use to label the slant height in all these formulas. And P, just like for the other formulas we've been working with, stands for the perimeter of the base. Okay, now the surface area is just your lateral area plus the area of one base. We only have one base for any pyramid, so the lateral area is going to be exactly what I wrote over there. 1/2 perimeter times the slant height. That'll give you the areas of all the triangular faces. And then capital B stands for area of the base. And what that would be would change depending on what type of pyramid you're working with. So if you're working with a square pyramid, that would have a different area formula for the base than if I was working with a pentagon. So we're going to talk about that in our examples. Okay, so for the first example, this is strictly lateral area. So that's 1/2 perimeter of the base times the slant height. Now, the perimeter of the base, remember, we're going to assume these are all regular, even if it doesn't say that in the directions. It does here. It says I have an octagonal prism, so that's 8 sides. So the perimeter of that base, it's telling me each side is 2, so it'd be 8 times 2. So the perimeter of that base is going to be the 16. That will be the base of every single one of the 8 triangular faces. Now, the slant height, is actually given to us in the problem, so I don't have to figure that out. It's just 4, and we're going to plug that in. So it'd be 1/2 times 16 times 4. Just multiply that out. This is going to be 32. We're doing a surface area, so anytime we're dealing with area, it's units squared. Here it's going to be millimeters. Scooch this up. Okay, now I have a square pyramid here. Find the surface area. So I'm going to do surface area. This is 1/2 perimeter of the base times the slant height plus the area of the base. Okay, now a couple things here. They don't give me the slant height. They give me the actual height, but that's not involved in your surface area or lateral area calculation. They're giving that to us here, so we're able to find the slant height. Now, I put a little question mark here. Whenever you have a height of any kind of a regular pyramid, this is a square base, if you have a height, it will drop directly in the middle. So if this entire side is 300, where that drops directly in the middle, we're just going to cut that little segment into 2, like, oh, if I extended it over here, we're just going to cut this into 2 equal pieces. So this would be 150. And let me just kind of outline what I'm looking at here. The height touches the base at a 90-degree angle, and I'm basically just going to take and use that little right triangle and do the Pythagorean theorem so we can find our slant height. So the actual height, the 321, would be one of the legs of that right triangle I highlighted. The 150, remember I had to cut the side of the square in half, so that's where I got 300 divided by 2 is 150. Those are the 2 legs of that right triangle. The slant height is the hypotenuse. Okay, so I'm just going to do this on my calculator real quick. 321 squared plus 150 squared. Now, this is a big number. I got 125,541. And I need to take the square root of that. And I don't get a nice number here, so what I'm going to do, just so my answer is more accurate, and you don't have to break down the radical in simplest radical form or anything like that, but since this did not break down to be a nice number, I don't want to round multiple times as I'm doing the problem, so I'm going to leave it like that. Okay, now the other 2 variables we got to fill in here are super easy. Perimeter of the base. If this is a regular figure, these all will be just number of sides times the side length. So 4 times 300 is going to give you 1200 for your perimeter of the base. And remember, that's the base of each of the triangles that fold up to this vertex. And then the area of the base, since it's a square, base times height, length times width, however you want to think about it, is going to be 300 times 300, or 300 squared, which is going to end up being 90,000. Okay, now all we have to do is plug this information all into the formula. So 1/2, perimeter is going to be 1200 of the base. Now remember, the slant height, I'm just going to type it in, since it wasn't a nice number, I'm going to type in an exact value, and I'll add the area of the base, which is that 90,000. Okay, sorry about that. Now, when you guys get onto the assignment, it's going to ask you to round these to the nearest 100th or maybe the 10th. It's not going to ask you to leave it in radical form. So I'm just going to type this out. So 1/2 times 1200 times square root 125,541. Now just remember, most calculators will pop up parentheses around a square root, so make sure you close that. If you're working with the type of calculator I'm showing you on the screen here, you just arrow over so the rest of it's not under the square root. And we're going to add 90,000, which will be the area of our base. So this first part's the lateral area, the 90,000 is the base, and that'll give us the total surface area. So my directions, if I go back here, say round to the nearest 10th. So I'm going to go 302,590 that 0.59, we're going to round that to 0.6, and this is going to be square feet. We are talking about a surface area here. Okay, now my third example, they don't always give you a picture, so sometimes you might have to kind of visualize what's going on. And I'm going to try my best to sketch a picture here. So it says find the surface area of a square pyramid. So square pyramid is named for the base. And my drawing is kind of going to look terrible, I'm sure, but I'm going to try to draw a pyramid here for you. The base edges are 10. And the slant height is 13. So the slant height, remember, you could touch it if you had a physical representation. And honestly, that's all we need there. So your surface area, remember, it's all those 4 triangular faces. So 1/2 perimeter of the base, each of the sides is 10, so it would be 10, 10, 10, 10, so it would be 40. And then the slant height is the height of each one of those triangles. So that first part is all those triangles. And then area of the base is just base times height, length times width, 10 times 10, that's 100. And so all we have to do there is multiply that out and add 100. So this is going to give you 260 for the 4 triangular faces, plus 100 for the base, so the total 360, and it said meters in the direction, so square meters would be my surface area. If they just asked me for the lateral area, I would just put the 260. Okay, I do have a picture, a little bit more complicated shape of a base here. Now, it says I have a regular hexagonal pyramid, so that means the base is a hexagon. Base edges are 8, so all the sides there around the hexagon will be 8, and they give us the slant height, so I'm just going to draw a little line here. This would be the height of each of those triangular faces is going to be 12, so we don't have to figure that out with the Pythagorean theorem. But what is tricky here is finding the area of the hexagonal base. Alright, so surface area here. Each of those triangular faces, 1/2 perimeter of the base times the slant height. Perimeter of the base, little note here, perimeter of the base is just going to be 8 times 6, which is 48. That's where I'm going to get that. And the slant height is given to me in the directions as being 12. And so what we have left is the area of the base here. Now, because the base is a hexagon, area formula for a hexagon, 1/2 apothem times perimeter. Now, if you guys remember, anytime you have a hexagon, when you drop the apothem, each one of these central angles is going to be 60. When I drop that apothem, it's going to be 30. Creates a 30, 60, 90 triangle for that little bitty triangle there. I'm just going to kind of highlight this here. Now, I need the apothem. That is the distance from the center to any side at a 90-degree angle, so I'm representing that here. If the base side is 8, so the whole side's 8, when you drop that height, it splits it into 2 equal pieces. And a little 30, 60, 90 triangle formula. You have your side, your short leg, your long leg, and your hypotenuse. Don't need the hypotenuse here. The short leg would be 4, and the long leg will be the apothem. So if this is 4, my apothem is just going to be 4 radical 3. So I'm going to plug that in there. And the perimeter is the same as the perimeter we used here, same base, so just 8 times 6, which is 48. Okay, so as I go for my calculator, I am going to actually do one quick thing, and that's going to be to put this in parentheses because I want to add the entire area of the base, so I'm going to kind of separate these as I do the problem here. So you can type a fraction or you can type the 0.5 times 48 times 12. So that's going to give me my lateral area. Okay, now I'm not rounding this multiple times, but I'm not going to leave it in radical form either. So I'm going to go ahead, I'm going to do 0.5 times 4. Then when you hit your square root button, make sure it usually pops up a parentheses. Mine looks a little different, but make sure you close the parenthesis after the 3 and then times the 48. So after I got the lateral area, I just hit equals and then I just started to type the rest. And It doesn't tell you in the directions here, but let's go ahead and round this to the nearest tenth. So 454.3, and this is going to be centimeters squared. All right, now this example is a work backwards problem. It's going to give me the surface area and have us find a slant height. So again, I don't have a picture here. Let me just try my best to kind of sketch a little square pyramid here, something like that. So the surface area is 175. Now, it says if we have a square pyramid, that means all the base sides are the same. So it says they're 5, so each one of those is 5. I need to find the slant height, which I don't know. So what I would do here, let's just use the surface area formula. 1/2 perimeter of the base times the slant height plus area of the base. Now, we have enough information to figure out what to plug in for the perimeter of the base. Just going to be, each of the sides is going to be 5, so just going to be 5 times 4, which is going to be 20. Now, I don't know the slant height, so that L is going to remain a variable, but I can find the area of the base, length times width, or base times height, however you want to think about it. It's just going to be 5 times 5, which is 25. So I'm going to plug in my perimeter of the base, which is 20, and my area of the base, which is 25, and then you have everything you need in the formula except for the slant height. So we're just going to simplify this. Half of 20 is 10, and that area of the base is 25. So we're just solving this like a normal equation. So let me move the 25. I get 150 equals 10 times my slant height, and then all you got to do, just divide both sides by 10. So your slant height is going to be 15. And then this would just be inches because it's not an area, it's just a dimension. Okay, now the rest of what we're going to focus on is lateral area and surface area of a cone. And so this is extremely similar to how you find the lateral area and surface area of a pyramid. The only difference is the base has to be a circle, and the formula is going to look really similar as well. Okay, so for a cone, kind of picture an ice cream cone, might be a filter on a coffee maker or something like that. Cone shape is going to look like this over here. The base is circular, so you have a radius, and just like a pyramid, you have the height of the actual object that drops from the vertex to the base right in the center, so it'd be the center of the circle. And then you have the slant height. So if you physically had a cone, you could touch the slant height. You could not touch the actual height because it would be inside the figure. So we need the slant height for our lateral area, just like we do for a pyramid. Okay, now here is a net of a cone. So here's the base. Here's how this would wrap around. They're saying that this distance is going to be a circumference, 2 pi r. That's where that's going to come from. Now, this surface is not quite a circle, so this is kind of an odd formula here. But the lateral area is going to be pi times the radius times the slant height. So you just need 2 things here to find lateral area, just the radius and the slant height, and you're good to go. So this surface only, pi times the radius times the slant height. And then the base is just a circle, so the base is just pi r squared like a normal circle. So when you do the surface area, it's the lateral area, pi times the radius times the slant height, plus the area of the base. But if you're dealing with the cone, you know the base has to be a circle, so I'm just substituting in circle area formula. Okay, so like the pyramid, sometimes you might not know the slant height, or you might not know the radius, but you will have situations like we have here where you're going to have a right triangle, so you may need to use Pythagorean theorem. I need the radius here, which I don't have, so be mindful. The slant height should be the hypotenuse if you end up needing to find a right triangle. So I'm going to set up the Pythagorean theorem here. 12 squared plus my radius squared is going to equal my slant height squared. This is 225. Oh my goodness, sorry, I was looking at the 15. This is 144. This is 225. So I'm going to end up subtracting 144 from 225. So if you do that, you're going to get 81, and maybe you know this right away. Take the square root. This ends up being a nice number. This is just 9. If you don't get a nice number, just do what we've done in previous questions and leave it under square root. You don't have to break down the square root, but we want to not round multiple times so we can put in exact answers and round at the very end. Okay, so lateral area, pi times the radius times the slant height. So it's going to be pi times 9 times 15. Okay, I'm going to show you two things. So let's say the question says, let's leave it in terms of pi. So if I was doing that, all I'm going to do, 9 times 15, which is 135, write a pi next to it. Forgive me, this is inches squared. Now, if they ask you, let's say, to round to the nearest tenth, I know the question says leave it in terms of pi, but just want to show you both. So let's say it said round to the nearest tenth. Just type that 135 and your pi button. And so if it asks you to round it, I would say this would be about 424.1, and it's still inches squared. Now, all we got to do for surface area, this is pi times the radius times the slant height plus the area of that circular base, pi r squared. So if we got to leave it in terms of pi, we already know the lateral area part. This is 135 pi, so I'm just going to leave that be. 9 squared is 81, and these are like terms, so you can actually add them together and leave it in terms of pi, just 135 plus 81. And so in terms of pi, 216 pi, we're still inches squared. And then just in case the question asks you to round to the nearest tenth, all you're going to do is take that 216 times your pi button, and just in case, this is about equal to 678.6 inches squared. So in terms of pi means pi is part of your answer. You don't want to actually multiply that out. If it says round to the nearest tenth, you're going to go ahead and include the pi in your calculation. I have two work backwards problems here, and so I'm going to go through, if I'm giving you a surface area or I'm giving you a lateral area of a cone and asking you to find maybe a radius or a slant height, how do I go about finding that? So surface area of this cone is 24 pi. You can see I don't know the slant height. So this is pi times the radius, which I do know, times the slant height, plus pi times the radius squared. So I am able to plug in the radius here. This is 24 pi. This would end up being 3 times the slant height times pi. So the slant height's a number, we just don't know what it is yet. Plus, this is going to be 3 squared, 9 pi. Now I'm going to go ahead, subtract 9 pi. Pi's don't cancel out. This is just like combining like terms, so I'm subtracting this. So this is going to be, 15 pi. And then 3 times the slant height times pi. Now everything's being multiplied here, so you can actually divide by 3 pi, right, in the same step. Cancel the 3, cancel the pi. Now, because I'm dividing here, I'm not subtracting like I did in the previous part, this does cancel out, pi divided by pi. And then all we're left with, 15 divided by 3 is 5, and then that's going to be our slant height. And then this would be in inches because that's the dimensions they give me. Okay, just a little bit different. Lateral area is just pi times the radius times the slant height. So this gives you 126 pi. Now this is tricky. They're giving you the diameter here, so make sure you do the radius. So radius should be 9 divided by 2, which I'm just going to put in here as 4.5. And then I don't know the slant height again. It's a mystery for this problem. So again, this is really less work than the previous question because all we got to do, I'm going to divide both sides by pi times 4.5. Okay, now the pi's are just going to go, so literally all you're going to grab from your calculator, just do 126 divided by 4.5, and 28, and this is going to be inches again, is going to be my slant height. Okay, the very last problem in all this is called a composite solid. So this is not a specific shape that we have a formula for, so we got to figure out what this is made up of. So I do have a cylinder, and then I have a cone. So if I want to find the surface area, I'm going to find the areas of everything that I could touch with my fingers. So let's do two things. I'm just going to say I have a cylinder and I have a cone. They're kind of fused together at their base. So let's look at the cylinder here. Now, in terms of what I could touch, because they're fused together, the cylinder, we could touch the lateral area that wraps around, and we could just touch one base. So I'm going to take my surface area formula for a cylinder, which is just going to be 2 pi r(h), that's the lateral part, and instead of two bases, because these are fused together, I can only touch one of the bases. So I'm just going to go pi r squared. So there's no 2 in front of that. Just how I'm modifying this a little bit. Now, the part of the cone I can touch, because these bases are fused together, I can't touch the base. So for the cone, it's just the lateral area only. So pi times the radius times the slant height. So we just got to plug in numbers here. The radius for both the cone and the cylinder, since they're meeting exactly with each other, this is going to be 6 here, because I've got 12 as my diameter, so my radius is going to be 6. The height of the cylinder is the 22. Radius is going to be the 6. Radius is going to be 6 for the cone. Now, for the cone, I need the slant height, which unfortunately I don't know. I know the actual height is 8, so the slant height is not shown to me, but I can use the Pythagorean theorem. So I've got 6, this is 8, this is your slant height. If you do 6 squared plus 8 squared, that's your slant height squared. 36 and 64 is 100. We're just going to take square root, so we're going to get a nice number for our slant height as 10. Okay, now you can actually leave this whole thing in terms of pi. For the first term, I'm going to do 2 times 6 times 22. This is 264 pi. Pi times 6 squared, 36 pi. And the lateral area of that cone, 6 times 10 is 60. These are all in terms of pi, so I'm just going to add them all up. 264 plus 36 plus 60. And I'm going to get 360 pi. I don't have any labels here on the diagram, so it'd have to be units squared because we are still talking about surface area. And then if you needed to go to the nearest tenth, just do 360 times pi.